Okay, it's Tuesday, May 19th. I don't know which one of you guys have bunk beds at home, but there's definitely a reason why a lot of families don't like them. It's because you fall off of them. Now, when you fall off your normal bed, it doesn't hurt that much, but when you fall off a bunk bed, it probably hurts a lot more. Why? Because you're higher up. You have more potential energy. Kind of makes sense. Similarly, if you're sleeping on the edge of a mountain, a lot more dangerous than sleeping on a beach. Why? Because you have more potential energy. So just be careful when you're on the bunk beds, please. So on page 91, this was our potential energy notes. And remember, potential energy is the energy related to the stored energy based on its position. So the higher something is, the more energy it's going to have. The more mass something has, the more energy it's going to have. Or depending on the gravity, the more energy it's going to have. For our purposes, we're going to stay on Earth. So here are some more examples of potential energy. These are not gravitational potential energy, but these are all examples of how energy is stored and then can be converted. So if you play pinball, the spring, when you pull it back, it has potential energy. So when you let it go, it gets converted to kinetic energy. When you pull back bow and arrow, the string of the bow gets the potential energy, so the farther back you go, the more potential energy you have. Would you let go, the faster the arrow is going to go. And lastly, even food is considered potential energy. It's chemical energy. And so the chemical energy is just waiting there, and when you eat it, you convert it into usable energy through cellular respiration. All right, so our equation once again is potential energy is equal to mass times gravity times height. And so there's the part 2 of the activity on page 90. So we're going to use the equation to calculate the potential energy of different objects. So we have 4 calculations that we should be doing. We have the penny on top of the desk. We have the bowling ball on top of the desk. We have the penny on top of the Empire State Building. We have the bowling ball on top of the Empire State Building. And we're going to see which one of these 4 has the most potential energy. Now, I kept it on Earth for all 4 just to kind of keep it simpler. So, let's do the penny on the desk. The mass is 0.0025 kilograms. It's on Earth, and the height is only 1 meter. So if that penny falls off the desk, how much potential energy does it have? So we're going to take that and go to the calculator. Then the gravity is 9.81 meters per second squared. Our height is 1 meter. We calculate it, we get joules. Ooh, that's a very small number right there. I have 0.024525. Let's convert it to 3 significant figures. Boom. So that's not very much energy at all. So if a penny falls off of a desk and hits you on the head, probably will be okay. Now let's try a bowling ball. It's 5 kilograms, same gravity, same height. So do you think it's have more or less potential energy? Let's find out. We have 5 kilograms. And voila, we have 49.05 joules. So we convert it to 3 significant figures. Right there, 49.1 joules. So a lot more energy than the penny. So if a bowling ball fell on you, probably be hurt. Now here's an interesting one. Let's go back to the penny. So we have the penny, but now it's on top of the Empire State Building, which is 381 meters tall. Do you think that's going to have more or less than the penny on the desk? Well, probably more. But what about the bowling ball on a desk? Which one do you think is going to be more? The penny on the Empire State Building or the bowling ball on top of the desk? So what we can do is we can put that into our equation. We have 381, and you can find out for yourself. So once you find all 4 of these, what you're going to do is you're going to see which object has the most potential energy, and does that make sense? All right, So good job, you guys. I'll finish off with a quick song about the potential energy formula. See you tomorrow.
Objects dancing with energies, potential like a car static on a hill. It's staying still. Onto potential, gravitational energy from our Earth's gravity type. You calculate it with the equation. Mass times standard gravity times height. Now here's an example. What is the potential of a 4 kg rock on a 10-meter cliff? 4 times 9.8 times 10